Okay, so the next functional group. So the next functional group is, okay, let's just start the difficult one now. You are familiar with esters, and other than this, you have done in O levels about the carboxylic acid also. Okay, there are two new functional groups for you, which are very similar with these two. The new one are aldehyde and the ketones. Okay, so let's make topic more easy so that you can learn these and two new functional group, aldehyde and the ketones. They are more difficult. You can see most of the reactions are based on aldehyde and the ketones and the carboxylic acid. Okay, so let's start with the first one, aldehyde. This is new for you. Aldehyde. This is a group actually. Okay, what is aldehyde? Um, with aldehyde, we can discuss two things together. Aldehyde, and it is very similar with carboxylic acid. Yes, because अलग अलग याद करेंगे ना तो थोड़ा सा मुश्किल हो जाएगा. So you can learn aldehyde along with carboxylic acid. Carboxylic acids are the weak acids. They are called organic acids. You know very well. Okay, they can undergo with the neutralization reactions also, because these are the weak acids. Okay, aldehyde and the carboxylic acid. I guess you know about the carboxylic acid. Let me show you the structure of carboxylic acid. Carboxylic acids are, let's make with ethane now. 2 carbon. Now you know the shape of molecule should be trigonal. OH. Yes, oxygen always make double bond. This is carboxylic acid. I guess you know about carboxylic acid. You can fill rest of the bond with the hydrogen. Let me show you how many hydrogen should you fill here so that you should know how to make a structure. 1, 2, 3 hydrogen. Because you can see the second carbon that is already making 1, 2, 3, 4 bonds. Yes, one with the carbon, two with the oxygen, and one with another oxygen which is attached with the hydrogen. This is the structure of carboxylic acid. Okay, I'll tell you the name later. What is aldehyde? Aldehyde is little similar. Little similar. Um, it has little similarity as carboxylic acid. You can see the carboxylic acid, and now you can see the structure of aldehyde. Let's make with the ethane so that you could learn it. 2 carbon. Okay, there are 2 carbon. For example, they are joining with the single bond. Now, what is aldehyde? You can see in carboxylic acid, there is double bond with the oxygen. In aldehyde, there is double bond with the oxygen. What is the difference then? Here we have OH now, and here we have hydrogen only. This is aldehyde. Now you can learn aldehyde very easily because aldehyde is new for you now. You haven't discussed aldehyde in O levels. It was not included. So you can see the double bond. What is this? Aldehyde. Everything is different. I mean, there is similarity between structure. The properties, the reactions, everything will be different. This is aldehyde. In carboxylic acid and in aldehyde, there is one similarity that in both the structure, there is double bond with the oxygen. But in carboxylic acid, the carbon is making another bond with OH, and there is only hydrogen. I mean, you can learn like this. Wait, you can shade this thing so that you should know. You can shade this thing, this hydrogen and this OH. This is the dissimilarity between these two. Now, let's write the name. This is ethane, carboxylic acid. This is, you know very well, ethanoic acid. Ethanoic acid. This is ethanoic acid. What about this one? This is aldehyde. We know very well that carboxylic acid has a suffix which is oic acid. We are using oic acid as a suffix for the carboxylic acid. So ethanoic acid, butanoic acid, pentanoic acid, hexanoic acid. But what about aldehyde? What is the suffix of aldehyde? Let me tell you the suffix first. The suffix for aldehyde is L. We usually pronounce it Al, but this is Al. See, there are two carbon now, so it is ethanol, ethanol, butanol, pentanol, hexanol, heptanol. So sometimes they will give you structure, and sometimes they will give you the word equation. You can see I mean, they may ask you that give the XYZ reaction with the ethanol. So you should know what is ethanol. Ethanol. This is some aldehyde. Then you should know what is the structure of aldehyde. Because first you have to draw the structure, then you can react something, then you can see which bond is going to be broken. So you can see ethanol and the aldehyde and the carboxylic acids. There is similarity on a structure only. Everything is different. So ethanol, butanol, hexanol, pentanol, and for the carboxylic acid, ethanoic acid, butanoic acid. Let me tell you one more thing here. We do have some complex structure. No? Sometimes we would be having any carbon chain in which you can see some carboxylic group, you can see some halogen group. That's what we have to discuss in upcoming class. Or there could be some, for example, aldehyde group. Then how many suffix you are going to use? So we do have, I mean, for few things we have a prefix also. Sometimes we have to use prefix, especially for carboxylic acid. Sometimes you would be having some complicated structures. So you don't have to use oic acid at that time. Instead of this, you can use a suffix, carboxy, carboxyethanol, for example, carboxybutanol. It depends. So carboxy is prefix. Is it clear to you?
Yes.
Okay, let's move to next now. Aldehyde and the carboxylic acid. Okay, I'm not removing the board right now because the other two are also a little similar. Okay, let's start with Easter, because you're familiar with the Easter. Okay, Easters. What are Easters? Easters are, Easters are going to give you Easters are going to give you a polymer. I mean, two monomers will join together by Easter linkage. They are going to give you a polymer in bio. Okay, so what is Easter here? Let me show you the Easter. Let's make a carbon chain. One carbon, the second carbon. Ester is usually made up of one carboxylic acid and one alcohol. We have to discuss this detail in the upcoming chapter. There is a chapter on Ester. So see the three carbon. Let me change color so that you could check the functional group. See, oxygen, one more oxygen, and then carbon chain continue. I'm not following shape of molecule here. Otherwise, this oxygen should be here. Bond pairs. Let me follow the. Wait. Let me follow some shape of molecule here because you have to follow it here. What is this? Ester. Okay. So see. Oxygen. You can see there are three bond pairs now. Carbon. Carbon. I guess that is enough. This is Ester. You can make more carbon. That's not a big deal. Okay. All right. So let's start. Or if I want to make it easy for you, so you can remove this carbon. If you want to make your structure simple right now, just for the functional group, so you can make it like this. Okay. Let me make another one also. That is ketone, so that I could discuss both of them together. Ketone. Okay. What is ketone? See, This is very similar to the ester. Carbon, another carbon. Okay. Then there will be double bond with the oxygen. And then there will be one more carbon, no more oxygen. And definitely you have to follow the shape of molecule. Okay, so you have to do like this. That carbon would be connected anything. You can check the difference between ketone and the ester. What is the similarity? I mean, in aldehyde and the carboxylic acid, you can check the similarity. In both, you can see the double bond with the oxygen. But aldehyde has hydrogen, while carboxylic acid has OH with the carbon, which is making double bond with the oxygen. In ester, you can see carbon is making double bond with the oxygen and it is having one more oxygen. You can check this one also. This one is also included. I mean, carbon is making or carbon is joining two oxygen, one with the double bond, one with the single bond. What about ketone? Carbon is making double bond with one oxygen and there is no more oxygen. Okay, what is the name? After that, I'm going to tell you the detail. How many carbons are there in ketone? 1 to 3 carbon. Okay. What is the suffix? On. O-N-E. Propanol, propanol, propanoic acid, propanon. Oh, propanon. O-N-E. You can see this is propanol. Butanol, hexanon. This is ketone. You can see, wait, you can see this thing. See, on. In ketone, there is on. So this is also on. Separately, we can pronounce it like one. Ketone and the propanol. What about ester? This is ester. Okay. So yes, esters are a little difficult. This part and this part. This part will be named first. This part. Okay. So the right hand part is ethyl. There are 2 carbon. Ethyl. And you can check the left side of the part. There are 2 carbon also. Ethanoate. Ethyl, ethanoate. I mean, for ester, we have to, I mean, I just told you that ester is just like a polymer. It is made up of 2 monomers. So you have to name separately. While ketone, there is no any rule like this. You have to count all the carbons together and you just have to decide the name. There are 3 carbon total. That's it. Like there are 4 carbon in, there are total 4 carbon and ester, you cannot call it butanoate. No, you have to break the chain into 2 portions from here, from the functional group part. Then you have to name this part first, ethyl, methyl if there is 1 carbon, butyl if there are 4 carbon, hexyl if there are 6 carbon, and then you have to name this part, which is right now there are 2 carbons, so ethanoate, butanoate, hexanoate, heptanoate, pentanoate, whatever is present. Any confusion?
No.
Okay. Now, check one more thing here. You can see that aldehyde and the we have discussed that aldehyde and carboxylic acids are a little similar. There is only one dissimilarity in the structure. Just for the functional group I'm talking, I mean, just for the structures. And ester and ketones are a little similar in terms of the structure. You can say the properties will be totally different. The reactions are totally different. But you have to check one more thing here. Or you have to learn that thing also. I mean, these are the tricks so that you could recognize aldehyde and the carboxylic acid correctly in a chain. Okay, you can see in aldehyde or in carboxylic acid, the functional group is present at the last carbon, at the corner carbon, you can say. While ester and the ketone functional group are present in the middle carbon. Because in ester, the carbon, which is making double bond with the oxygen, and that will make single bond with another oxygen that has to join another carbon. that has to join another carbon. If you say no, miss, ester can be there at the end of the carbon chain. So see, let's make ester at the end of the carbon chain. This is the last carbon. You have make double bond with the oxygen, and you have connect one oxygen. And now you're saying no, miss, this is the last carbon. So oxygen always make double bond. If you say no, miss, this oxygen is already making double bond. So what about this carbon, bhai? There should be any other carbon which is making bond with the carbon. So if you say no, miss, this oxygen is making single bond with the carbon and it is making other bond with the hydrogens, because to end the chain, you can say. So you can see this is carboxylic acid. So keep in your mind that ester and the ketone can be seen or can be present in the middle of the chain. Ketones and the ester will be present in the middle of the chain. Carboxylic acid and aldehyde both are present at the corner carbon, not in the middle carbon. You can see, I mean, you can never make carboxylic acid with the middle carbon. See, 1, 2, 3. For carboxylic acid, you have to make one double bond with oxygen, one OH. Okay, see, double bond with the oxygen. How can you attach OH here? You can see carbon is making 5 bonds, which is impossible. So aldehyde and carboxylic acid will not be attached with the middle carbon, which is present in the middle of the chain. Carboxylic and aldehyde can be attached with the corner carbon only. And ester and ketones can be seen in the middle of the carbon. Yes, any confusion now?
No, it's clear to me.
Okay. So these are the functional group, and this is how you have to learn this. You know, aldehyde and the, aldehyde and the ketones, they are confusing sometimes, but you can see all the reaction in your past paper are based on ketones, aldehyde, and the carboxylic acid. So you don't have to mix up these things. And this is how you can learn these the functional group, that aldehyde and the carboxylic acid, they are little similar. Ester and the ketones, they are similar. One dissimilarities here. Okay, I have told you the name also. Okay, let's move to, we have discussed alkene, arene, halogen, alcohol 4, 5, 6, 7, 8. 2 left. There are total 10 function group. The next two, the next two are amines and the nitriles. Amine and the nitriles. Amine, which are going to give you amino acids, means they are giving you protein, amines, and the nitriles. Nitriles. What is the difference? This is really easy. See, amine means there is a carbon chain, and at the last you would be having amine functional group like this. What is amine? NH2 actually. It will be attached like this now. You know, nitrogen make a triple bond. Nitrogen make triple bond always. 1 bond with the carbon, 2 with the hydrogen. So this is amine group. Okay, let's move to the nitrile, because nitrile, the word is showing that there is nitrogen involved. So for the nitriles, we have this. Let me show you. 1 carbon, for example, 1 more carbon. I'm giving you example with the ethane only right now, so that you could you could check the difference between the functional groups. Okay, 2 carbon. You know, carbon can make 4 bonds. You can see this carbon, it is making 4 bonds, 3 with nitrogen, 1 with previous carbon. But keep in your mind, with this carbon, you cannot attach any hydrogen now, because carbon is already making 4 bonds. You can see this is the single bond of the carbon with previous carbon, and there is triple bond with the nitrogen. This is called nitriles. Amines, NH2. Nitriles, nitrogen will make triple bond with the carbon. In amines, nitrogen will make single bond with the carbon and other 2 bonds with the hydrogen. But in amine, nitrogen is making single bond. In nitriles, nitrogen is making bond in one go. It is making triple bond with the carbon. What will be the name? For example, amines. For the amines, I have used 2 carbon now. So it will be simple. It will be ethyl amine. Ethyl amine. It will be ethyl amine. I'll tell you about ethyl thing also, means alkyl. I'll tell you about the alkyl also. Ethyl amine. And what about nitriles? There are 2 carbon. So this is ethane nitrile. Ethane nitrile. There is no gap between these two. Keep in your mind. But here for ester, ethyl ethanoate. There is a gap between ethyl and the ethanoate. Butyl gap means space. Butyl space pentanoate. This is how you have to name the ester because that is made up of 2 monomers. I just told you. But in amine, this is ethylamine, methylamine, butylamine, hexylamine, nitriles, ethane nitrile, methane nitrile. What else could be there? Butane nitrile. This is the nitrile. And these are the functional groups which are included in your syllabus. Functional group can change the properties of your chain. Just because of the functional group, the properties could be changed. You can see the amines. And I mean, we just discussed the carboxylic acid. Those are the acids. They can undergo with the neutralization reaction, you can say, and amines. They can help to give you amino acids, and then they can give you protein. So the functional group can change the properties of the chain, especially chemical properties. Carboxylic acids have different chemical properties. Amine has different chemical properties. Arenes has different chemical properties. These are the functional groups which you should remember here. Let me tell you another thing. I just use word alkyl. Alkyl. Alkyl is not functional group. Oh, wait. I have to tell one more thing because that is not included in the list of functional group, but there are, 40% reactions are based on that thing. I forget to tell you that thing. That is alkyl chloride. Alkyl chlorides. Or wait, that is called alkyl halides. Alkyl halides. It depends now which halogen you are attaching with the alkyl thing. So definitely it could be alkyl chloride, alkyl something. Wait, what is alkyl? Halide could be, it could be chloride, it could be bromide, it could be iodide. Okay, what is alkyl? This is a free radical. Now, what is free radical? Wait, free radical, you should know about the free radical because we have to discuss free radical substitution. And whenever you are making any reaction of organic chemistry, so for example, we do have some reactions, no? Electrophilic reaction, nucleophilic reaction, nucleophilic substitution reaction, and that's all. So you have to make I mean there are reaction mechanism. So you have to make your reactant as a radical. You have to convert your reactant into the radical. Then a student get confused that what is a radical. Let me tell you what is radical. There is a definition for the radical. Forget about free radical right now. Simple radicals. What is radicals? Radicals which have all the radicals are having, yes. So radical which have, no, not free. Radicals which have, see. Oh, I'm unable to write it here. Yes. One unpaired electron. Everything in the world which have one unpaired electron is called free radical. Anything in the world which have which have one unpaired electron is called free radical. Oh, I have made a mistake in the spelling of electron. You can correct it yourself. Okay, so what is free radical? Simple. Free radical means anything Any species which have one unpaired electron. Keep in your mind, it could be atom, it could be molecule, it could be compound, because most of the students say, miss, free radicals are atom only. No, dear, it depends. Free radicals are not on the atom. Free radicals are not on the atoms. Free radical could be any species, molecule, compound, or atom which have one unpaired electron. For example, see, let me tell you one more thing about the free radical. You have to note that point also. Free radical which have one unpaired electron, but keep in your mind, not charged particle. It is not charged particle. Means it should be neutral. ऐसा नहीं कीजिएगा किसी को इलेक्ट्रॉन गेन करवा के आप कहें कि दिस इज अ फ्री रेडिकल. No. Free radical is not charged particle, that is neutral. This is the main thing about the free radical, and this is the only confusion which students are facing right now, because most of the teachers say the free radicals are charged particles sometimes. No. Okay. So free radical which have one unpaired electron, and that is not charged particle, means that is neutral. Okay. One more thing which you should know about the free radical. It is not charged. It is neutral. It has not gained any electron, and it has not lost an electron. It is not charged, neutral. It have one unpaired electron. It have one unpaired electron. It is highly reactive. You can see this is a new point in organic chemistry. The free radicals are highly reactive. The free radicals are highly reactive because they have one unpaired electron. They want to make bond with that unpaired electron. They want to pair that electron also. Now let me give you the example. Let's say, for example, let's say hydrogen. You know about the hydrogen? Hydrogen has only one electron in the valence shell, and there is no any other electron inside the hydrogen atom which could be paired with this one. So you can see this is neutral. Yes. There is no charge on the hydrogen. Yes, there is no charge on the hydrogen. And when there is no charge on the hydrogen, it's simple. This you can see this is having one unpaired electron, highly reactive. Have you ever used atomic hydrogen in any reaction? No. We always use diatomic hydrogen. Then we do something like bond breaking. Then we make new bonds. We haven't seen any atomic hydrogen because this is highly reactive. It has one unpaired electron. Are you getting my point? Is there any confusion?
No, it's clear.
Okay. So yes. So hydrogen is free radical. Why this is the reason that we haven't seen hydrogen, atomic hydrogen in our reaction. We always use diatomic hydrogen, then we break the bond, then we make new bond. That's how we do in organic chemistry. So what is free radical? Which is highly reactive. In physical chemistry or in inorganic chemistry, we always discuss that metals are highly reactive, and sodium is highly reactive, potassium is highly reactive. But in organic chemistry, organic chemistry is all about hydrocarbons, or you can say organic chemistry is all about covalent bonding. We may have polar covalent bonding sometime, or the one end of the chain could be polar, other end could be non-polar. It depends. But for the reactivity, we have to discuss the radicals only. We don't have to discuss here that carbon is less reactive and oxygen is more reactive, this is that reactive. No, we have to discuss the reactivity of the compound in terms of radicals. Hydrogen is a radical. Reason? One unpaired electron, not charged. This is a neutral one. This is highly reactive. Okay, let me show you one more example. Keep in your mind, unpaired means it doesn't have any electron to pair with. So in atomic form, Monoatomic chlorine, the alone chlorine is a free radical. See, how many chlorine belongs to halogen? 7 electron. 1, 2, 3, 4, 5, 6. You know very well about, wait, this is 7. You know very well about the subshells, and you know very well that how we are arranging electron in a subshell in a pair form. Like we have shells and then we have subshells, then we have orbitals, and every electron are there in a pair form in the orbitals. So you can see, I mean, all the electrons are paired because the students say, Miss, all the electrons of the chlorine are unpaired. No, pair. They are paired with each other. These two electrons are paired with each other. They are also pairing with each other. That's why they are not taking part in a bonding. No? Only this electron will take part in a bonding for the chlorine. Chlorine always makes single bond. So this electron is unpaired. Yes, the chlorine have one unpaired electron. It is not charged. It is neutral. So it is highly reactive. So if you have any compound later on when we discuss reactions, so when you have any compound, and if you want to make that compound reactive, or if that compound is not reacting, for example, you have any reactant which is not reacting right now. If you want that, I mean, if you want to break the bonds of that reactant, for example, I'm just giving you the example, you can bring a free radical. It is highly reactive, now it will attack on that compound. It will break the bond of that compound. This is highly reactive. Free radical can also make some other thing a free radical. It can also create a free radical, or it can make something neutral. It can be, it can pair its electron with other thing to make some molecule, you can say, like Cl2. You can see in Cl2, both are chlorine and both are free radicals, but together they are giving you a Cl2 gas, which is not reactive. Cl2 gas is not reactive. No? That's why it exists in a molecular form. But sometimes your free radical can create more free radicals. Are you getting my point?
Yes.
Okay, so this is all about the atomic form. So it is clear that atoms can be free radicals. What about compounds? Because I have seen that most of these students were telling me in a previous classes, and they were telling me, Miss, I mean, the compounds cannot be free radical. Or if you are saying that any compound could be free radical, so it must be charged compound. No, let me show you. The free radical has, you know, it has some typical concept, but this is not that much difficult. If you can understand the topic, it will be easy for you because the whole organic reactions are based on free radicals. Okay, this is, for example, methane. Let's make methane. Okay, let's make methane. Wait, oh, let's make it more easy. For example, this is carbon. So, you know, carbon has four valence electron. No? So let's say this 1, 2, 3, 4. But before the bonding, definitely these two will be pure and these two will be pure. Definitely these two will, I mean, all four will be in a pair form. Okay, let's bring hydrogen for the reaction. Okay, I'm bringing one hydrogen. This will become CH. It is not charged yet. It is sharing one electron with the hydrogen. It is not charged. It is not gaining or losing electron. Keep in your mind, it is not gaining or losing electron. So it is not, I mean, CH is not charged. CH is not charged. It has 3 electrons, which can make more bonds. This is not charged particle. That's what you should know here. For the free radical concept, you can say. You can bring one more hydrogen. You can bring one more hydrogen. What is this? CH3. Do you think that CH3 is a charged particle? No. CH3 is not charged particle. How can we say that CH3 is a charged particle? No, this is not a charged particle. Reason? Simple. CH3, in CH3 molecule, carbon is making 3 bonds with other hydrogen, and one unpaired electron is still there, which can make bond with one more hydrogen to give you CH4. CH4 is charged? No, there is a sharing of electron. Hydrogen is not losing or gaining electron right now. It's sharing electrons. So this is CH4, for example. This is the methane. Methane is not a free radical. But yes, if you remove this hydrogen from the methane, let's remove it, it has become CH3. It has become CH3. And you know, CH3 is not charged particle. I have removed hydrogen along with the electron of hydrogen. The electron of carbon is still there. Carbon is not gaining or losing electron. You can see there are 3 hydrogens which are sharing their electron to the carbon. So carbon is also sharing its electron to the hydrogen. There is no charge on the carbon. If I'm removing hydrogen from the carbon, there is no charge on the carbon. So you can see carbon has 1 unpaired electron. So right now, carbon is a free radical. Oh, no, not carbon. This whole compound is a radical now. This is a free radical now. And what is the name of this compound? Because it was alkane. It was alkane. And what is the name of this alkane? Methane. Now this is not alkane because it is not following the Jodl formula of the alkane. I mean, according to the alkane, it should have, you can say, it should have 4 hydrogen. This is not alkane. Then what is this? It is the free radical of alkane. This is not alkane. This is alkyl now. Free radicals are called alkyls. Means methyl, butyl, pentyl, hexyl. If you have hexane, you can remove 1 hydrogen. It will not make your hexane a charged particle. I have told you everything here. But hexane will become hexyl. Means now that is not alkane, that is alkyl. It can, now it is more reactive because it is a radical now. Yes, any confusion?
So what would you call the hydrogen?
Sorry?
What would you call the hydrogen that was acting as a free radical?
Hydrogen is not acting as a free radical. This whole compound is a free radical, which is called methyl. I have removed.
No, I mean the previous example.
This hydrogen, atomic hydrogen.
Yeah.
This is atomic
Yes.
hydrogen. This is atomic hydrogen. Simple. This is atomic hydrogen. This is a free radical. This is acting as a free radical. But actually, wait. We are making alkyl from alkane. Hydrogen is not alkane. So it will not become any alkyl. You don't have to, I mean, the hydrogen and the chlorine alone, they belong to inorganic side of the chemistry. So we don't have to discuss them in terms of alkyl and alkane. I just have given you the example because we are going to use chlorine as a free radical in free radical substitution reactions. So they are simple free radicals, hydrogen radical, chlorine radical. But here, this has become, I mean, in organic